Let's take a look at two hard questions in integration by parts. To start with, let's look at number 13. In this question, you will see there are two expressions, x cubed and e to the power x squared in the expression. In order to apply integration by parts, we have two choices. One is we put x cubed together with dx, or we choose to put e to the power x squared into dx. Let's consider the first case, which is in red first. In the first one, you will see that differentiate x to the power 4 will give you 4x cubed and dx. As a result, your expression will become integration, and I have 1 over 4 in the front, e to the power x squared, and dx to the power 4. It doesn't look like a favorable result because now you turn the question from power 3 into power 4 in the integration by parts. So that's why I have a hesitation to continue and try to look at the yellow one. In order to put e to the power x squared into dx, we consider differentiate or d e to the power x squared. By chain rule, first of all, we have e to the power x squared first. Afterward, differentiating 2x squared, you have 2x in the front. So it will be good because now you will consume 1x in the expression. So as a result, your expression will now become x cubed in the integration sign, and then multiply to 1 over 2x, and then dx squared. So as a result, it looks like a more favorable outcome, which gives you 1 over 2 integration of x squared and d e to the power x squared. In this case, you can start going ahead on the integration by parts, which gives you integration of u dv will be giving you uv minus integration of v du. So going back to the expression as a bottom, now you have 1 over 2 in the front, and then x squared e to the power x squared at first, minus integration of e x squared. If you are okay to skip a step, then you should know this is coming from the differentiating x squared, so which gives you multiplying 2x and then dx. As a result, your expression becomes simpler because you have 1 over 2 x squared e to the power x squared, which is partially integrated, and while for the other expression will become minus integration of x e to the power x squared dx. It is a successful integration by parts because at first you have x cubed, but now you have only an x. That means you're going to succeed in the integration by parts. Next, we go ahead to continue the integration. Now the expression becomes an integration of x e to the power x squared dx. We need not to do integration by parts once again, because if you are reading the expression carefully, it can be done by substitution. For example, we can let u to be x squared, and so that's why du will be 2x dx. As a result, the second expression becomes integration of x ex squared dx will be equal to 1 over 2, and then e to the power u du. Then you can obtain the answer very quickly, which gives you 1 over 2 e to the power x squared, or should be e to the power u first, and then plus c. So that's why it goes to 1 over 2 e to the power x squared, and then plus c finally. As a result, the final answer will be also including the first term, which gives you 1 over 2 x squared e to the power x squared, minus 1 over 2 e to the power x squared plus c. And that's the end of the question. To conclude, the main point to solve this problem will be, can you seek for suitable u and v so that the power of x is decreasing? I repeat, it should be focusing on how to decrease the power of x until there is no x here. Next, we come to take a look on number 14. Number 14 is a very special question because it consists of log. Normally, if it consists of log, because there is no way to put with dx together, so as a result, normally log 3x in this question will be our u, and v will be our x directly. So after that, what does that mean? That means now, by applying the results of integration by parts, it will be uv, but we write as x log 3x minus. Afterward, you have integration of v, that means your xe, and then differentiating log 3x afterward. After that, the magic about this choice of u and v, which seems to be a little bit weird, will come up. And then you have integration of x. The outcome of differentiating log 3x will be 1 over 3x multiplied 3, and then dx afterward. As a result, your expression will be very simple, giving you x log 3x and then minus integration of 1 dx finally. So as a result, the outcome becomes it's just x log 3x minus x plus c. And we complete the question. So next time when you see things about log, which is related to integration by parts, for example, integration of log x, the simplest one, or integration of x log x dx, then so you bear in mind that we should keep log x to be our u. This is a little bit tricky when you are dealing with a question of log in integration by parts.